Hi, I'm Sanallah Khan. Welcome all of you in this comprehensive course of electronics, which is all about how to learn electronics through practicals in 30 days. This course is a comprehensive skill development training session. Before I should proceed onward, let me introduce myself first. I am holding master degree in electronics and physics, along with a past experience of more than 35 years of teaching, development, designing, troubleshooting, and manufacturing of lab equipment in many disciplines of electronics. After spending many years in public and private sector, I finally came upon to know that learning is always by doing. It is true because there is a difference between simulated environment and physical practical work. Simulation is based on ideal conditions and parameters, whereas physical environment is rough and tough. Experience gained at shop floor level is of worth importance, keeping in view all the prerequisites and requirements. I finally came upon to launch this course for you. Don't forget to watch a 3-minute video at the end of this introductory session, because it will guide you the theme and about the methodology that we have adopted for you to learn. This course is being provided in 2 soft copies. You will enjoy this course by going through these manuals.
Theoretical portion covers all the topics in detail which are of primary concern. In this portion, you will cover all the basic concepts of electronics on which the structure of this subject is built upon, including in-depth knowledge of components, their characteristics, their uses, their applications, and their readout values. The practical lab work includes 30 video demonstrations of electronics practicals. Beside all that, wave shifts are also introduced. Upgrade the knowledge of a training so that you should become familiar and used to with the advanced level applications. These experiments are being performed on a training console, which is one of our basic manufacturing unit. This training console is not a part of this course. It would have been provided later on if required by any of the students. This course provides in-depth knowledge at grassroots as well as at advanced level. The major portion covered in this course is related to the following topics of electronics: familiarization with discrete components, power sources used, formulas used in electronics, instrumentation, integrated circuits, solid-state electronics, digital electronics. After completion of this course, you will be able to prototype and understand the working of many electronic circuits, and this course will provide you all the basic knowledge to move forward in further advanced levels in electronics. This course is equally beneficial for not only beginners but for students and hobbyists as well. Some more about to say. Sensors are introduced to use them in a circuit physically by their own. This is an effort to enrich everyone who wants to learn electronics very quickly and fast without seeking any help from outside. It would build up your confidence to a level of minimum dependency. This equally facilitates the student, hobbyist, technician, engineer, or any non-technical person of the community. This course provides equal opportunity for different users to develop keen interest in the subject of electronics. Very basic circuits are introduced along with maximum attention on measurement techniques and physical testing by their own. Even one can learn a lot about the subject of electronics without consulting any teacher. This is the main aim and my contribution for all those who are interested to learn electronics in a short period at very reasonable and affordable cost. With the passage of time, You will feel more comfortable to perform all the given experiments of your own choice and would gain in-depth knowledge of having hands-on experience through confidence and courage. Let me tell you about major contents of experiments that would be performed during this session. In experiment 0, you will learn basic electronic concepts and the console electronic parts. In experiment number 1, you will learn to measure DC voltages using digital multimeter. In experiment number 2, you will learn to measure alternate voltage by using digital multimeters. In experiment number 3, you will learn to measure resistances using resistor module. In experiment number 4, you will learn verification of Ohm's law. In experiment number 5, you will learn to measure current through a component. In experiment number 6, you will measure the output voltage of a solar cell. In experiment number 7, you will measure the DC output voltage and the current in series combination of solar cells. Experiment number 8, you will measure the output DC voltage and the current in parallel combination of solar cells. Experiment number 9, you will learn how the resistance of LDR, light dependent resistor, varies with light and how parallel combination of LDR becomes more sensitive to light. Experiment number 10, you will learn how to use lamps in parallel and series combination and find voltage across and current through the circuit. In experiment number 11, you will learn how to measure resistances. In experiment number 12, you will learn what kind of change occurs during moisture in a moisture sensor, which is normally called a rain detector. Experiment number 13, you will learn how voltage divided networks are used with sensors and how V output is taken across the resistor. Experiment number 14, you will learn how voltage divided networks works with sensors when V output is taken across the sensor. Experiment number 15, you will learn how variable resistor is tested and how it is used with respect to a fixed common point. Experiment number 16, you will learn how variable resistor is used with voltage divided networks. Experiment number 17, you will learn to study operation of a reed switch. Experiment number 18, you will learn to study the behavior of push switches and how do we make with them AND gate and OR gate applications. In experiment number 19, you will study the behavior of the lever switches. In experiment number 20, you will study the power dissipation due to heating of a resistor. In experiment number 21, you will study the behavior of SPDT switch. In experiment number 22, you will study the properties of thermistors. In experiment number 23, you will learn how diode is used to convert alternating current into a direct current and how we can test a diode. In experiment number 24, you will learn how to use LEDs, light emitting diodes, and some of their applications. In experiment number 25, you will understand how 7-segment display is used and how digits are being formed. In experiment number 26, you will observe the demonstration and the working principle of windmill and DC voltage generator. Experiment number 27, you will learn the behavior of a relay. Experiment number 28, you will observe charging and discharging of a capacitor. In experiment number 29, you will learn logic gates. In experiment number 30, you will design a digital logic circuit for an automobile warning system. Okay, gentlemen, today we are going to perform experiment number 23 now, in which you will learn how diode is used to convert AC current into DC and how we can test a diode. Parts of the console, you will use digital multimeter, diode as a rectifier module number 14, lamp module number 3, connecting wires, and variable DC power supply module number 18 now. Procedure adopted. Diode can be used in forward biased or reverse biased. Let us see figure number A, B, and C and D. Now this is your figure number A, this is figure number B, this is figure number C, and this is figure number D. As you go on increasing the value of your DC source voltages, there would be no increase in the voltage drop across the rectifier. It will remain constant at 0.7 volts. These voltages are the basic requirement of the rectifier to conduct in a forward biased configuration. So in this circuit, when you increase the voltages from 0 to 0.7 volts, you will observe there would be no voltage drop across this resistor up to 0.7 volts, whereas the voltage drop across the diode will definitely increase from 0 to 0.7 volts. As long as 0.7 volts are reached, the diode will start conducting the current through this circuit now. So the flow of current will introduce a voltage drop across the resistor. I allow the oscilloscope to show us both of the wave shapes. So you can see over here, that is the input waveform and that is the output waveform. Now look at this, how this waveform looks like when you merge these two waveforms with each other. I am bringing the output just to overlap the input. Channel number 1 shows the wave shape of your input voltages, whereas channel number 2 shows you the wave shape of your DC output voltages after rectification. Now we make connections according to this diagram. First of all, I measure the input voltage. These voltages are about 12 volts AC now. What about the value of the voltages across these two lamps? So look at this, how much the voltages are. They are around about 4.8, approximately 5 volts. Now we have seen that the voltage drop across these two lamps are how much? They are equal to 5 volts. Whereas the source voltages are how much? They are equal to 12 volts. So that is the end of your experiment number 23 now. And thank you very much for joining us.